Welcome back to our discussion of basic hydraulics. We're going to continue now with an introduction of the concept of flow, and then we'll be moving on from there. In an irrigation system, flow of the water is going to be dependent on the number of sprinklers or drip emitters that are working at the same time, so in a given irrigation zone or area. Each segment of pipe in an irrigation system can have different amounts of flow. And in the case of overhead spray or rotor type irrigation, that flow is commonly measured in gallons per minute. Or in the case of drip irrigation, that flow is commonly measured in gallons per hour. And it's really important to know what the flow is for each section of pipe in an irrigation system so that you can determine friction losses and what size pipe to choose so that you have an adequate amount of pressure in the irrigation system that you design. Now we're going to talk a lot more about friction losses in the next lecture, but it plays a big role in flow, so you're going to hear me mention it a few times here as well. In this example, notice that each sprinkler has a flow of 10 GPM, that's given to you here, and that they're all on one lateral line. So let's consider what the flow would be in the sections of pipe between the sprinklers. First, between sprinkler 3 and 4 right here, the flow required to operate sprinkler number 4 is 10 GPM. Again, that's given here. So that's the amount of flow in this section of pipe. As you move backward toward the valve, though, that is going to increase and be cumulative. So here in this section between sprinklers 2 and 3, the flow required would be 20 gallons per minute. You need 10 gallons per minute for sprinkler 3. You need 10 gallons per minute for sprinkler 4. So the flow required in this section of pipe is 20 gallons per minute. And then you just keep adding that cumulatively as you move back toward the valve. Now here in this section, moving from the valve toward the sprinklers, 40 gallons per minute are required of flow because you're operating 1, 2, 3, 4 sprinklers at 10 gallons per minute. So 4 sprinklers times 10 gallons per minute is 40 gallons per minute. In this example, it's a little bit more complex. There are 3 lateral lines controlled by one valve in this case, and the flow entering each of these lateral lines is going to be determined by the number of sprinklers on that lateral. But the flow from the valve must carry enough water to supply all of the laterals. So let's talk about what that would mean. Again, given here, sprinkler heads are requiring 10 gallons per minute. So the furthest sprinkler on each lateral requires 10 gallons per minute of water, and 10 gallons per minute are what are going to be needed to flow in this last section of pipe. And then just like we did in the previous example, you just sum those, they're cumulative as you move back toward the valve. So here on each of these laterals where there are 4 sprinklers requiring 10 gallons per minute, a total of 40 gallons per minute is going to be required at the beginning to supply all of those sprinklers. And just like that is cumulative, it's also cumulative here. So these laterals are each requiring 40 gallons per minute to supply the sprinklers, but the line running from the valve to these laterals has got to supply all of those. So it's 40 gallons per minute times these 3 laterals, meaning that 120 gallons per minute are required coming from this valve to operate this particular arrangement of sprinklers with these laterals. Now let's look at a typical drip irrigation setup. This lateral, again, it's very similar to what you've seen just with drip emitters, but this lateral has 100 drip emitters. Only 4 are shown, and this break indicates that there are a significant number in between the 4 that are shown here. But flow here is expressed as gallons per hour, and drip tubing would be used for the lateral lines as opposed to PVC pipe. The flow in the last section of tubing before emitter number 100 would be 2 gallons per hour because each of these emitters requires 2 gallons per hour. So what would the flow for all 100 emitters be? Again, it's just cumulative as you move back from the end of the lateral all the way to the valve. And so in this case, there are 100 emitters on this line. They require 2 gallons per hour per emitter. And so the total requirement in terms of flow for this arrangement would be 100 gallons per hour. Now if you wanted to convert that to gallons per minute, just so you kind of get a sense of difference here, that 200 gallons per hour divided by 60 minutes in 1 hour gives you 3.33 gallons per minute. That's what's required for this particular design. Now it's important to remember that the flow in the pipes and the tubing has to be known before the total system pressure can be determined. And in the example so far, the flow to each emitter or sprinkler was given, but what if you didn't know that? And consider the situation where you're designing your own irrigation system. You're going to be looking at all of the options as far as sprinkler components and what you might choose. So in that case, determining the flows for an irrigation design and the components or sprinklers you might choose, you'd want to use manufacturer specifications. And in catalogs of irrigation equipment, it is specified what the flow is for a given sprinkler or drip emitter, and that's the information that you would use as you were beginning to design your own system. Now in an installed system, you might also need to determine what the flow is, and there are different ways to do that, including things as simple as looking at the water meter or installing flow sensors on the system. So to sum up this discussion of flow, it's important to remember that sprinklers and drip emitters have a specified flow rate at certain pressures. And these flow rates are published by manufacturers. They're available in catalogs, they're available online, there are lots of resources available for you there. The total flow rate in an irrigation system sums the flow for all the sprinklers or emitters that will be on at any given time. So that's really important to know. It's which ones are going to be on at any given time. And you need to know the flow for every section of pipe in your designed system to estimate friction loss in those pipes. So here's a little something to think about before we move on to our next section in basic hydraulics.